Today we will start our quadratic equations lecture number 3. So let's start. Today we'll cover these topics. First one is graph of quadratic function. Now this topic is important because there is no specific question on this topic, but many questions here, this concept is used in many questions also. Okay, so we will not do any specific question on this topic today in this lecture, but in our next lecture we will study location of roots, and then we will do this, okay, this type of questions, because it is important there. Okay, so yeah, we will cover this, and we will cover range of rational function, where we will discuss about two type of special type of rational functions, which is quadratic upon quadratic and linear upon quadratic. Okay, so let's start. So first we will start about graphs of quadratic function. So how we can represent a quadratic function? We can represent a quadratic function by fx, which is equal to ax square plus bx plus c, where a is not equal to 0. Okay, so now if I tell you to draw the graph of this, you can draw actually 6 type of graphs. Okay, you can draw 6 type of graphs, but the basic nature of all those graphs are that those are all parabola. Okay, so we can write that basic nature is what is parabola. Okay, always. Okay, so yeah, now we will try to draw the graph. So we can make two special cases. Okay, two cases. First one is for a is greater than 0, and second one is for a is less than 0. Okay, a cannot be equal to 0, so there are two cases only: a is greater than 0 and a is less than 0. And for each of the cases there are 3 graphs. Okay, so let's try to draw. Okay, so let us draw the corresponding axis. So here these are for a is greater than 0. Okay, and this will be for a is less than 0. Clear? I hope it is clear to you. Okay, okay, let me make it. Okay. So now let's try to draw the graph. So how is a parabola nature? Parabola is something like this. Okay, parabola is something like U-shape graph. Okay, so now for a greater than 0, okay, for a greater than 0, the mouth of the parabola will be upwards always. Okay, for this all 3 graphs we will get a upward facing parabola. Okay, for a is greater than 0. Okay, and for a is less than 0, we will get downward facing parabola. So that is the difference only. Okay, now how we will differentiate the graphs. So for this graph, or the first graph, for these both cases, the first graph will be when d, what is that, this is discriminant. Okay, discriminant when d is let us take first is d is greater than 0. Okay, for d is greater than 0, I will make it something upwards. Okay, when d is greater than 0. The second one is for this both case, the second one is for d is equal to 0, and the third one is d is less than 0. I hope you know all the meaning of discriminants. Okay, all the nature of discriminants, I discussed that. Okay, so yeah, now we will draw the graphs. Okay, it's very simple. See, now for d greater than 0, for d greater than 0, what it means that if d is greater than 0, then we will get two distinct real solutions of that quadratic equation. Okay, or quadratic function. Clear? We will get two distinct solutions for a quadratic function. Clear? Or you can say two distinct roots of quadratic function. So yeah, so you know that a graph, how much times a graph cuts the x-axis is the number of roots. Okay, so here you can say that for d greater than 0, there are two roots, right? There are two distinct roots actually. So the graph will cut the x-axis 2 times. Let us take the roots are here and here. Okay. So the graph will something like this. Clear? The graph will be something like this. Okay. The graph will be something like this, if you see. I cannot draw perfectly, but you can understand. Okay. The graph will something like this. It will be a parabola. It will be a parabola where it will cut the x-axis at two distinct points. It will cut x-axis at two distinct points. So it's the graph for d greater than 0 and a greater than 0. For a is less than 0, the graph will simple like this. Okay, the graph will be a downward parabola. Okay, cutting the x-axis at two points, two distinct points. Clear? For this is for d greater than 0 also. Okay, so this is the graph for d greater than 0, for a is greater than 0 and a is less than 0. Now we will talk about for d equal to 0. For d equal to 0. Now for d equal to 0, the we will get same solution. We will get repeated roots. Okay, repeated same roots. So the graph will cut, that will be wrong language. The graph will touch one point of the x-axis. Okay, the graph will touch one point of the x-axis. So our graph will something like this. The graph will touch one point of the x-axis. Clear? So this is for d equal to 0. Same like that, here the case will be something like this. The case will be something like this. Clear? The graph will touch one point of the x-axis. That means there are two repeated roots. Okay? Two equal roots. For this, that is d equal to 0 also. You can see here. Okay? Now for d less than 0, it's like d less than 0 means what? It means that there are no real roots. So what we can say, actually there are no real roots. So the graph will neither cut or neither touch the x-axis. So it will be something like this. And for this case, it will be like this. Okay. This is for d equal to 0 and this is for d less than 0. Clear? It will neither touch or nor cut the x-axis because there are no real roots, right? Okay, I hope it is clear to you. So this is the basic of graphs. You can see that all the graphs are parabolas. Okay, but here the graph will cut at two distinct points of x-axis. Here it will touch only, here it will neither touch or nor cut. Clear? So yeah, this is the concept. Now there are many things to know about it. It is not ended. Okay, first thing, what is this called? These points, you can see these points are called the vertex of the parabola. Okay, these points are called the vertex of the parabola, and we can easily write the coordinate of it. We can easily write the coordinate of it. I am writing for one only because these will all be the same. Okay, so let me name it P. Let me name it P. So what will be the coordinate of P point? So the coordinate of P point will be the value of x. The value of x coordinate will be the point where ax square plus bx plus c, this is minimum or maximum, right? If a is greater than 0, it will be point minimum, and for a is less than 0, it will point maximum. You can see the graph also. Okay, so at a greater than 0 point, it will point the minimum, and at a is less than 0, then we will get maximum of a quadratic function. The graph also tells that. Okay, so here you can say that for P point, what will be the coordinate? Now the value of x for which the fx, has minimum for a greater than 0 is what? This is minus b by 2a. I discussed in a previous lecture. Please see that before watching this. Okay, please see that before watching this. Clear? And what will be the coordinate of a y coordinate? What will be a y coordinate? Okay, what will be a y value? So that will be the maximum or minimum value itself. Okay, that will be the maximum minimum value itself. So what is that? For a greater than 0, the minimum value of a quadratic function is what? Is minus d by 4a. Minus d by 4a. Clear? So this is also p, this is also p. Every vertex is p, okay, every vertex are p, and the coordinate of p is minus b by 2a comma minus d by 4a. Okay, for a less than 0, it will point the maximum. It will point the maximum. This point will point the maximum. Okay, you can see this is here, and here this will point the minimum because a is greater than 0 and here a is less than 0. Okay, that's why all lectures are important, because those are interconnected. Okay, so make sure to see that before. Clear? So yeah, that is the concept. That is the vertex of, that is the coordinate of vertex of the parabola. Clear? So yeah, now the graph is, maybe you can visualize a quadratic function, how it looks like, how it will be. Okay, what will be the coordinate of the vertex. Now there is one more point where it will cut the y-axis. It's very easy. Put x equal to 0, so you will get fx equal to c, f0 equal to c actually. So it will cut, if we extend the y-axis to, so it will cut at y equal to c. It's very simple. It will cut at y equal to c. Okay, so yeah, the main things are the coordinate of the vertex, the nature of the graph. These are the main things of it. Okay, so this is the things. Now in this topic, our last thing is sign determination. Sign determination. So what is that? Let us they give a graph. Okay, think that they give a graph. Clear? It is like something like this. This graph is something like this. Clear? Now they said that to find the signs of a, b and c. Okay, what is a, b and c? This is a graph of fx equal to ax square plus bx plus c. So they told to find the signs of a, b and c. Okay, that means either a is less than 0 or a is greater than 0, b is less than 0 or greater than 0, c is less than 0 or greater than 0. So that is the signs. Okay, so how we will tell it? This is very easy. You can easily say. First, C sign determination is very simple. Okay, you can see that the graph is cutting the y-axis at positive direction, right? So C is particularly greater than 0, because if you put x equal to 0 here, you will get C. So C is the cutting point at y-axis. Okay, so C is greater than 0, first thing. Now A is also very easy. Sign determination of A is also very easy, because this graph is a upward parabola. This graph is a upward facing parabola. So that means A should be also be greater than 0. A is also greater than 0. Now the thing is B. How you will determine the sign of B? Okay, so that's also a thing, how we will determine that. Now if you see that this is the coordinate of vertex, now this is the x value of this is minus b by 2a. That means this point is this. Okay, this point is this comma 0, right? So yeah, so now what we can say actually, that now see here that this vertex is at the positive direction of x. Check the positive or negative. Is the vertex at the positive direction of x-axis or the negative direction of x-axis? Because we will work with the x coordinate. So check for x, do not check for y. Okay, else it will be wrong. So check the x. Okay, so this is at the positive x-axis, right? Vertex is at positive x-axis. You can see that this point. Okay, so minus b by 2a is greater than 0. Minus b by 2 is greater than 0. Now see here, a is greater than 0. So if we multiply both sides by 2a, then sign will not change. So we will get minus b is greater than 0. So we will get b is less than 0. So we determine the signs of a, b and c. This is very simple. Just analyze the graph and you can say. Okay, just you need to understand clearly what is the nature of the graph. You need to know everything about the graph, okay, to do this. Very easy thing. No problem. It will be here. Okay. Let us take another example. This is very interesting thing actually. So yeah, we will take now this. This is also very interesting, and I will do this myself. Now you will do this in homework. Okay, you will do this in homework. What is this? This is sign determination. Okay, this is sign determination. You will do this in homework. Clear? So let's check for this thing. Here you can say that y coordinate, you can see that the graph cuts the y axis at positive direction. Okay, so here we can say that c is greater than 0 as a result, or c is greater than 0 as usual, right? Okay, first thing is clear. Next thing is here. Now what we will do, we will do the sign determination of a. So that is very easy because the parabola is facing downwards, so a will be less than 0, right? You can see here I discussed many times about these graphs. Okay, so a is less than 0. Now about what is about the b, sign of b. So this vertex, this is at the negative direction of x-axis. So here it is minus b by 2a. So minus b by 2a should be less than 0, right? Because this is in the negative side of x-axis, so this will be less than 0. Okay, so now a is less than 0. So if we multiply both sides by 2a, then sign will be reversed. The sign will be reversed. Okay, so b will be less than 0. So yeah, this is very simple. Okay, now do this for homework and tell me in comments that what will be the signs of a, b and c for this graph. Okay, clear? So now our topic of graph is completed. Now what we will do, we will start our next topic, which is range of rational function. Now we will discuss about range of a rational function. Now there are we will discuss about two type of rational functions: quadratic upon quadratic and linear upon quadratic. Now these two methods are same, okay, but yeah, we will learn it. Now what is quadratic upon quadratic? It is something like y equal to ax square plus bx plus c upon let us take dx square plus ex plus f, something like this, and this is like y equal to ax plus b upon cx square plus dx plus e. Okay, so these two types are same, but okay, but we will do one method that is applicable for these two. Okay, so we will directly go to question because we will learn it through question. Now first we need to find the range of it. So to find the range of it, what we will do first? Our first step, I am writing the techniques here. Okay, I am writing the techniques here. So first step is cross multiply. Okay, cross multiply. Okay, so let us do it. So what we will get? We will get x square y plus xy plus y equal to x square minus x plus 1. Now our next step is make a quadratic in x. Okay, so yeah, bring all the term to what? To left hand side. So we will get y minus 1 into x square plus y plus 1 into x plus y minus 1. This is equal to 0, right? Okay, now we made this. Now what is our next step? Next step is put d greater than equal to 0. Now why you will put d greater than equal to 0? Because we need to find range of y, right? So x should be real. If x is not real, so how we will get a real value of y? So x should be real. So for x be real, we need to put d greater than equal to 0. So what is the discriminant of it? We will get y plus 1 whole square minus 4 into ac. So this is y minus 1 whole square. This is greater than equal to 0. Okay, clear? So here now what you will do, simply solve the inequality. So here you will get y plus 1 plus 2y minus 2, okay, into y plus 1 minus 2y plus 2. Now this is simple. I did it by a square minus b square formula because this is 2 into y minus 1 whole square. Okay, so this is greater than equal to 0. So we will get 3y minus 1 into, here what we will get, we will get minus y plus 3 is greater than equal to 0, or you can write 3y minus 1 into y minus 2, this is less than equal to 0. Multiply both sides by minus, so you will get it. Okay, so from here, you know, if you know how to solve inequality, you will get y belongs to, sorry, 1 by 3 comma 3 closed interval. Okay, now what is our next step? Our next step is check boundary values. Check boundary values. Okay, check boundary values. Now this is important. Now why? If you let us put y equal to 3 here, so we will get 3x square plus 3x plus 1 equal to x square minus x plus 1. So there is nothing cancelling. And if you put y equal to 1 by 3, you will get same. So there is no problem. So this is our answer. But in various cases, what it goes to that x square, x, all the terms will be cancelled out and resulting some odd things, wrong things. So we need to exclude that solution. Okay. Now we will do this. So what it is here, first what we will do, let us follow the things, follow the techniques. So first we will cross multiply, so let us do it. So we will get y plus yx squared equal to x squared. Okay, then we will get make a quadratic in x, so we will get y minus 1 into x squared plus y equal to 0. Now what, put d greater than equal to 0. Okay, so we will get 0, b is equal to 0, so 0 minus 4 y into y minus 1, this is greater than equal to 0, or y into y minus 1 is less than equal to 0. So from here we will get y belongs between what, 0 and 1. But check the boundary values. Okay, so if you put y equal to 0, then we will get x squared equal to 0, there is no problem there. If you put y equal to 1, we will get x squared equal to 1 plus x squared, and x squared will be cancelled out from both the sides, resulting 0 equal to 1, which is wrong, absolutely wrong. Okay, okay, so yeah, we need to exclude 1 from solution. So final answer is this. Okay, so this step is very important. Now this can be solved in another way. You can say that here, from here you can say that x square is equal to what? X square is equal to minus y upon y minus 1. Okay, now x square is always greater than equal to 0, so minus y upon y minus 1 should be always greater than equal to 0, or y by y minus 1 is less than equal to 0. From here you can say that y belongs between 0 and 1 open interval, because it is in the denominator. Okay, it is in the denominator, so open interval. So you can solve it like this. Now we will do our last question on this topic. This is from AIEEE 2006. Okay, pre-JEE mains you can say. So let's start. It's simply asking for maximum value, so let's do it. Okay, so y equal to 3x square plus 9x plus 17 divided by 3x square plus 9x plus 7. Okay, first what we will do? First cross multiply. So we will get 3x square y plus 9xy plus 7y, right, equal to 3x square plus 9x plus 17. Now make quadratic in x square. Follow the steps simply. Okay, you will easily solve this question. We will get 3 into y minus 1 into x square. Just do hurriedly. Okay, don't be slow here. Here we will get y minus 1 into 9x, right, plus 7y minus 17. This will be equal to 0. Now put d greater than equal to 0. So we will get what? Now here b squared is, b is this thing. So yeah, b will be 81 into y minus 1 whole square. Okay, don't be scared first thing. Don't be scared. Now we will get here what? 4 into 3 into y minus 1 into 7y minus 17. This will be greater than equal to 0. Right? So now solve it. Simple. Solve it. So let's do it. So 81 into y square minus 2y plus 1 minus 12 into, here you will get 7y square. Okay, don't be scared. I am always Lego. This is very large calculation, but if you do it clearly, you can easily get the answer. So do not be scared. Okay, so 7y square minus 17y minus 7y, so this is 24y plus 17. This is greater than equal to what? 0. So we will get 81y square. Okay, 81y square minus 162y plus 81 minus 84y square. Now this will be something like, yeah, 288, right? It will be 288y, 288y, and here it will be what? Here it will be calculated. Okay, so here it will be 204. Okay, it will be 204. This is greater than equal to 0. Don't calculate first, but maintain accuracy here. Okay, so we will get minus 3y square, and here we will get what? We will get plus, here we will get 6, here it is 2, yeah, 1 to 6y. Okay, minus, here what we will get? We will get 3. Okay, 2, 3, 2, and here 1, right? I hope it is right. Okay, let me check clearly. Okay, right. Okay, no problem. This is greater than equal to 0. Now we will get actually what? You can take 3 common. So take minus 3 common. So we will get y square minus 42y plus 41. Okay, y square minus 42y plus 41 is less than equal to 0. So this is actually 41. We can write it as minus 41 minus 1. So we will get y minus 41 into y minus 1 is less than equal to 0. Okay, so yeah, let me solve. Now y belongs between what? 1 and 41. Now we need to check. Now you don't need to check actually, because they are asking about maximum value. So maximum value will be 41. That will be the answer. Okay, that will be the answer. But for you, I am checking for y equal to 1. If you put y equal to 1 here, you will get 3x square cancelled out, 9x cancelled out from both sides, resulting 17 equal to 7. That is correct? No, that is not correct. So we need to exclude 1 from solution. Okay, so y belongs between open interval 1 comma 41 close interval. So 41 is the maximum value, so that is the question. So you can see that the calculation is large. Okay, but yeah, if you do in cool mind, you can easily get the answer. So yeah, thank you for this. And I am also telling you to watch the question solving lectures, because I will do most of the questions there. Okay, for that I am not doing here actually. Okay, so yeah, I will solve most of the questions there, so make sure to follow that. So thank you for the lecture. I will I need one more lecture to complete the quadratic equation, so I will bring it soon. Thank you. Bye. Happy learning.